Hello everyone. In this session, I'd like to explain the RC circuit. In the RC circuit, a resistance and the capacitors are connected in series. So this figure shows the RC circuit. At the time of the t is negative, a switch is open. At the time of the t equals 0, switch is gonna be closed. So current, voltage, and power changes with times in this RC circuit. Then we apply the Kirchhoff's loops rules in the RC circuit. At the t equals 0, switch is closed. The charge on the capacitor is increasing, so capacitor has a charge of the positive Q in this side and negative Q this side. This charge of the Q is changing with times, and the current is changing as well. At the t equals 0, charge on the capacitor is 0. The current is just only determined by the resistance. We expect the current is expressed epsilon over R. At the t equals infinity, current is going to be 0. Enough charge are stored in the capacitors. Final charge Q sub F equals C times the voltage of epsilon. Between the t equals 0 to the infinities, we apply the Kirchhoff's rules. So for the loop is epsilon minus IR minus Q over C, the voltage difference between the two plates of the capacitor. We are going to solve this equation. Current and charge. T is 0 to the infinities. We need to solve this equations. Current and the charge on the capacitors is related. I equals dq dt. Then you can substitute. Then this is a differential equation. dq over dt equals minus 1 over rc times q minus c epsilon. So we are going to solve these differential equations. So dq over dt equals minus 1 over rc q minus c epsilon. So the dq over q minus c epsilon equals minus rc dt. Then integrate in the both sides. Left hand side becomes log q minus c epsilon equals minus t over rc plus integration constant. So this means q minus c epsilon is expressed some integration constant exponential minus t over rc. So c0 exponential constant, this constant. Q becomes c epsilon plus c sub 0 exponential minus t over rc. So we need to determine this c sub 0. How can we determine this c sub 0? C sub 0 is determined with the initial conditions. This is initial condition. At the initial condition, at the t equals 0, charge, amount of the charge on the capacitor is 0. So we use this initial condition to this equation. So 0 equals c epsilon plus c sub 0. If you substitute t equals 0, exponential 0 is 1. So from this equation, c sub 0 minus c epsilon. Then you can return to this equation. Charge on the capacitor is expressed c epsilon 1 minus exponential minus t over rc. This corresponds to the final charge on the capacitors q sub f. Then current. Once you have a charge, current can be calculated by using this equation of the q by derivative of q with respect to times. Then this becomes epsilon over r exponential minus t over rc. And this is correspond to the I sub 0. Okay, so we have our equations. We'd like to express the current as a function of times, decreasing with times. We introduce a new term of the tau. Tau is RC. So this is correspond to the tau. Once the t becomes a tau, current is decreasing from the I sub 0 to the I sub 0 over E. So we call that this tau is a time constant or relaxation time. When a capacitance is large and or resistance is large, it takes long to store charges on the capacitors because the time constant becomes large. Then discharging capacitors, we remove batteries. Then we'd like to find what happens. Then at t equals 0, total amount of the charge are stored in the capacitors of the Q sub 0. Between the t equals 0 to the infinities, we apply the Kirchhoff's loops rules, minus IR, minus Q over C. Again, I equals dq dt. Substitute this equation. The equations becomes a dq over dt equal minus q over rc. dq dt equal minus q over rc. You can solve this differential equations very similar ways. Log q minus t over rc plus constant. So q is expressed as c sub 0 exponential minus t over rc. So again we use the initial conditions. At t equals 0, q is a q sub 0. Then you can find out c sub 0 equal q sub 0. So q, charge on a capacitor, is expressed q sub 0 exponential minus t over rc, or q sub 0 exponential minus t over tau. So charge on a capacitor is decreasing from the q sub 0, like a current in the last case. Then last one is the energy in RC circuit. So this is the basic equations. If we multiply the I in the both sides, epsilon I equal I square R plus I Q over C. So energy supplied by the battery can be calculated epsilon Q's because of the most left hand side. Because this term is a epsilon I dt becomes epsilon. This is dq over dt. So epsilon dq. 3 doesn't change, epsilon q. So this is the energy supplied by the battery. Stored energy in the capacitors can be calculated in the second term to the right. Integrate iq over c dt equal 1 over c q dq dt dt. Then 1 over c q dq 1 over 2 c q square 1 over 2 epsilon q. This is the stored energy in the capacitors. So this means half of the energy supplied by the batteries is dissipated in the resistors as heat. In these sections, I explained RC circuit. Okay, this is the end of this session.